Our solar system is a wonderfully dynamic place, filled with planets, moons, and asteroids, all dancing in an intricate ballet around our star, the Sun. Among the most enchanting of these celestial travelers are comets. You can think of them as giant, dirty snowballs, ancient relics left over from the very birth of our solar system some 4.6 billion years ago. They are fascinating collections of frozen gases, rock, and dust, often described as cosmic time capsules. For most of their existence, they drift silently and invisibly in the cold, dark outer reaches of space, far beyond the orbit of Neptune in a vast region known as the Oort cloud. Occasionally, a gravitational nudge from a passing star or another object can disturb one of these icy bodies, sending it on a long, looping journey towards the inner solar system. As the comet gets closer to the Sun, its journey becomes far more spectacular. The Sun's warmth begins to heat the comet's frozen core, or nucleus, causing the ice to turn directly into gas in a process called sublimation. This process releases a cloud of gas and dust that envelops the nucleus, creating a glowing, fuzzy atmosphere called a coma. This transformation from a dark, inert chunk of ice into a brilliant celestial object is what makes comets so captivating to watch from Earth. The pressure from sunlight and the solar wind, a stream of charged particles flowing from the Sun, then pushes this material away from the comet. This creates the magnificent tails that are the hallmark of any great comet. Often, a comet will display two distinct tails, a brighter, curved dust tail that reflects sunlight, and a fainter, straighter ion tail made of glowing gas that points directly away from the Sun. By studying the light from these comas and tails, we can decipher the chemical makeup of the comet, giving us profound insights into the primordial ingredients that formed our own planetary system all those billions of years ago. For centuries, comets were seen as omens, mysterious apparitions in the night sky. Today, we understand them as fundamental building blocks of our solar system. They are not just beautiful to look at. They are messengers from the past, carrying crucial information about our own cosmic origins. They may have even delivered water and organic compounds, the essential ingredients for life, to the early Earth. Every comet we study adds another piece to the grand puzzle of how our world and everything in it came to be. It's a direct connection to the dawn of our own star system, a story written in ice and dust. Here we see a diagram that shows a comet with its nucleus, coma, dust tail, and ion tail orbiting the Sun. While the comets from our own Oort cloud are endlessly fascinating, imagine the sheer wonder of discovering a visitor that didn't originate here at all. Imagine a snowball that was born in a completely different star system, one that has traveled for perhaps millions of years across the vast, empty expanse of interstellar space before stumbling into our cosmic neighborhood. This is precisely what makes the object known as 3’Atlas so incredibly special. It is not one of our own. It is a true alien, a traveler from a distant, unknown planetary system. It is only the third such interstellar object ever detected, a rare and precious guest, offering a glimpse into a world beyond our Sun's influence. This remarkable discovery was made on July 1st, 2025, a date now etched in the annals of astronomy. A team of scientists operating the NASA-funded Atlas Survey Telescope in Chile spotted a faint object moving through the sky. ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, is designed to scan the heavens for near-Earth objects, but on this day, it found something far more extraordinary. After carefully tracking its path and calculating its trajectory, astronomers realized this object was moving far too fast to be bound by our Sun's gravity. Its path was a hyperbola, meaning it was just passing through, destined to swing around the Sun and head back out into the galaxy, never to return. Once its interstellar origin was confirmed, the comet was given the official designation 3’Atlas. The 3I signifies that it is the third interstellar object confirmed to have visited us. Its journey began long ago, from an unknown star located in the direction of the constellation Sagittarius. hurtling through space at a breathtaking speed of approximately 130,000 miles per hour, this cosmic vagabond entered our solar system on a trajectory that would provide scientists with an unprecedented opportunity. Unlike the first interstellar visitor, Oumuamua, which was a strange rocky object, 3I/Atlas appeared to be a more familiar-looking comet, complete with a developing coma and tail. The arrival of 3I/Atlas sent a wave of excitement through the global scientific community. Here was a tangible piece of another solar system, right on our doorstep. What was it made of? How was its home star system different from our own? Was its chemical composition similar to the comets that formed around our sun? Or did it contain exotic materials we've never seen before? These questions sparked a massive international effort to study the comet in as much detail as possible during its fleeting visit. It was a race against time to unlock the secrets held within this icy messenger from a distant star. Section 3. A race to capture a fleeting moment. With 3I/Atlas on a one-way trip through our solar system, astronomers knew they had a very limited window to observe it. So, an unprecedented campaign was launched, bringing together the world's most powerful telescopes, both on the ground and in space. NASA and the European Space Agency, or ESA, directed their premier observatories to turn their gaze toward the visitor. The iconic Hubble Space Telescope, a real veteran of cosmic discovery, was one of the first to be called into action. It captured its initial images shortly after the comet's discovery in July 2025, providing an early estimate of its nucleus size, somewhere between 1,400 feet and 3.5 miles across, potentially making it the largest interstellar object ever seen. As the comet continued its journey inward, its appearance evolved dramatically. On its way to the Sun, it passed by Mars on October 3, 2025, and reached its closest point to our star, an event known as perihelion, on October 30th. This close solar encounter caused the comet to brighten significantly, as the increased heat vaporized more of its internal ices. Hubble revisited the comet on November 30th, capturing stunning new images from a distance of 178 million miles. These pictures revealed a beautifully complex object, a bright glowing nucleus surrounded by a vast coma of gas and dust, stretching an incredible 24,855 miles wide, with a long, elegant tail trailing behind it. The observational fleet extended far beyond Hubble. NASA's STEREO mission, designed to study the Sun, also tracked the comet's progress. ESA's JUICE spacecraft, on its own long journey to Jupiter, managed to capture images of 3I/Atlas on November 2nd, showing a clear coma and hints of two tails. Looking ahead, the powerful James Webb Space Telescope is scheduled to observe the comet later this month, in December 2025, hoping to analyze its chemical composition with unparalleled precision. Every instrument pointed at the comet adds a new layer to our understanding, creating a multifaceted portrait of this extraordinary object. The comet is now heading away from the Sun, on a path that will bring it closest to Earth on December 19, 2025, though it will remain at a very safe distance of about 170 million miles. After that, it will make a final planetary flyby of Jupiter in March 2026 before continuing its outbound journey into the interstellar void. The coordinated efforts of over a dozen spacecraft and countless ground-based observatories represent a monumental achievement in planetary science. This global collaboration ensures that we will gather as much data as humanly possible before our fleeting visitor disappears forever back into the darkness between the stars. A stunning Hubble Space Telescope image of Comet 3I/Atlas shows its bright coma and long faint tail against a backdrop of stars. Studying an object like 3I/Atlas is about so much more than just witnessing a beautiful celestial event. It represents a rare, direct link to the chemistry and physics of another star system. The comets in our own solar system tell us the story of our origins, but they can't tell us if our story is typical or unique. Are all planetary systems built from the same basic set of ingredients? Do they form in the same way? Interstellar comets are like probes sent from other cosmic laboratories, carrying the answers to these fundamental questions. By analyzing the light and materials coming off 3I/Atlas, we can perform a sort of chemical autopsy on a piece of a faraway world. The data gathered from this visitor will allow scientists to compare its composition directly with that of our own comets. Using spectroscopy, astronomers can break down the light from the comet's coma and tail into its constituent colors, revealing the chemical fingerprints of the elements and molecules present. They will be looking for water, carbon monoxide, carbon dioxide, and other organic compounds. If the composition of 3I/Atlas is very similar to our own comets, it would suggest that the building blocks for planets, and perhaps even for life, are common throughout the galaxy. This would have profound implications for the search for life elsewhere in the universe. Conversely, if 3I/Atlas reveals a composition that is wildly different from what we know, that would be just as exciting. It would show that the galactic cookbook for forming planetary systems has more variety than we ever imagined. Perhaps its home star had a different chemical makeup, or the disk of gas and dust from which it formed had unique properties. The detailed images from Hubble, showing features like jets and a sunward anti-tail, also provide clues about the comet's physical structure and how it's breaking apart, offering insights into the mechanics of comets formed under different conditions than our own. As 3I/Atlas recedes from view, the treasure trove of data it leaves behind will be analyzed by scientists for years, and likely decades to come. Its brief passage through our solar system is a powerful reminder that we are part of a much larger galactic community. We are not isolated. The space between stars is not entirely empty, but is traversed by messengers from other worlds. Each interstellar visitor, from Oumuamua to Borisov, and now Atlas, adds a crucial new data point, helping us place our own solar system in its proper cosmic context. This alien snowball has given us a priceless gift, a glimpse into the vast, interconnected nature of the universe.